All right, Math 8, we've made it to the last lesson of the unit, 6-10. We're going to add and subtract with scientific notation. This is a little bit of an extension. You probably won't see too much of this on the test. It's kind of going a little bit beyond what we would normally do. But, you know, we've divided, we've multiplied, we've looked at scientific notation. We might as well see what happens when we add and subtract with it. So this is more of a stuff you might see as like extra credit questions or something like that. Here we go. All right, so we have done multiplication and division with scientific notation in the previous lessons. So let's go ahead and do this. 2.5 times 8. Is it 2.0? Let's see, 2.5 times 8. Syntax error. 2.5 times 8. Yeah, it's 20. Yeah, not 2.0. What was I thinking? So that gives me 20 times 10, and then I'm supposed to add these exponents, -4 plus -10. So I get 20 times 10 to the -14th power, because I got two negative numbers. I add the numbers, keep the negative sign. Now this one is too big. I need to take a power of 10 by moving this decimal over here, and that means I have to give a power of 10 over here. So final answer would be 2.0 times 10 to the -13th power. Do you have to put these decimals on it, like 2.0? No, you don't have to do that. You'll see it a lot with scientific notation, where that first number, like if there's nothing after the decimal, they'll put 0. I don't know why. It's just how things are. Next one. 0.36, divide by 4. I'm going to guess that that's going to be 0.8. 0.36 divided by 4. 0.9, I was off. All right, it's 0.9. All right, so we get 0.9 times 10 to the -5 minus 7. Okay, so we end up with 9 or 0.9x, and then -5 minus 7 is -12. I need to give this one a power of 10. That means I'm going to take a power of 10 over here. So I end up with 9.0 times 10 to the -13th. All right, so when we add and subtract scientific notation, it's very similar to the idea of combining like terms, which we did at the beginning of the year. So here I've got like terms. Like terms are when the base, x, and the exponent are the same over here. So here I've got a base of x, exponent of 4. Base of x, exponent of 4. Since both of those things are the same, these would be considered like terms. And when we have like terms, all we do is combine the coefficients. So 10 plus 12, I get 22x to the 4th. So this is like saying I've got 10x to the 4th, and then I've got 12 more of the x to the 4th. How many x to the 4th do I have? I got 22. So on this one, they are like terms. I've got a base of y, exponent of 5. Base of y, exponent of 5. Those are like terms because they have the same variable to the same power. And we're going to just look at our coefficients, 8 and -12. So here's 8, here's -12. 8 minus 12 is -4, and then y to the 5th. So this has 8y to the 5th, and I take away 12y to the 5th. I'm left with -4y to the 5th. Again, we've got the same base to the same power, a to the 3rd, a to the 3rd. So I'm just going to look at those coefficients of -6 and -8. I'm going to combine them. -6 minus 8 is -14. And then the a to the 3rd stays the same. So in each of these situations, the coefficient was the only thing that changed. The base and the exponent stayed the same. And that's what is going to happen when we do our scientific notation. So in this problem here, I've got 7 times 10 to the 3rd plus 8 times 10 to the 4th. Now those bases are not the same. Well, the bases are the same. The exponents aren't the same. Base of 10, exponent 3, exponent 4. Okay, so those are not like terms. We cannot combine them. So what we're going to do is we're going to take this and make it down to a base of 3. So we're going to take a base over here to make it the third power, which means I have to give a 10 over here. So I took a 10 over here to make it to the third power, and I'm going to give a power of 10 here to make it 80. So sometimes the first step is you need to convert it so that the exponents are the same. They were not. I had 3 and 4. So I converted this one by giving a power of 10 here and taking a power of 10 there. And now we're both to the 10 to the third power. Step 2, we add or subtract the coefficients and leave the 10s alone. So the coefficients are 7 and 80. 7 plus 80 is 87. And the coefficients stay the same, 10 to the third, just like they did up here. Sorry, I said coefficients. The variables, the bases stay the same. Just like over here, the variables always stay the same. 10s are kind of like our variable in this situation, so they didn't change. And then once you get to the end, you might have to convert so that this number is between 1 and 10, which we do. We go ahead and take a power of 10 here, and then give a power of 10 here. So is it possible that you could have instead come over here and given a power of, gave a power of 10 here and took a power of 10 there? You could have done that too. You could have changed this one into 0.7 times 10 to the fourth. That was another option. I just kind of always make my numbers bigger without decimals. Decimals tend to throw people off, so you can do it the other way. Anywho, here we go. Let's go ahead and do this. Okay, so the first thing we're going to do is check to see if we have like terms. 10 to the negative second, 10 to the negative second. Oh joy, we do have like terms. So since we have like terms, all we have to do is say 6.0 plus 7.0. That comes out to 13.0 times 10 to the negative 2. So we didn't need to convert. So we jumped to step 2 and we add or subtracted the coefficients and left the base 10 alone. Now we do need to convert it because this is too big. So we take a power of 10 and give a power of 10. So we end up with 1.3 times 10 to the negative 1. Negative 2 plus 1 is negative 1. Next one, do we have like terms? We got 10 to the 8th, 10 to the 8th. Yes, we have like terms. So we can take the coefficients, 9 and 2, and since it's a subtraction problem, we're going to do 9 minus 2. So 9 minus 2 is 7. And then we just leave the base of 10 the same as 10 to the 8th. We don't need to convert it, so we're done. Next one. This one, we've got a little bit of a problem here. We've got 10 to the 6th and 10 to the 7th. So I'm going to take a power of 10 here and give a power of 10 here. So when I do that, I get 31 times 10 to the 6th because I took a power of 10 and I gave a power of 10. Now these are both 10 to the 6th power. So I can do 31 plus 4, the coefficients I can just combine, which is 35, times 10 to the 6th. And now I have to take a power of 10 here and give a power of 10 here. Final answer, 3.5 times 10 to the 7th. All right, last one. We're almost there. Now this one can throw some people off a little bit. So here we've got 1.1 times 10 to the negative 7th and 9.0 times 10 to the negative 8th. So I can either take a power of 10 here to make this a bigger number, or I can give a power of 10 here to make this a smaller number. It's up to you. You can do it either way. I'm just going to do it to this one over here. So negative 8, this is 10 to the negative 7th, 10 to the negative 8. Okay, so I want to add 1 to negative 8 to make it negative 7. So I'm giving a power of 10 over here. that means I'm going to take a power of 10 there. So this would leave me with 0.9 times 10 to the negative 7th. And this is a subtraction problem. So if I've got 1.1 minus 0.9, that would be 0.2. They're both 10 to the negative 7th, because I made them that way. And there we go. But at this point, this is too small, so we need to give a power of 10 and take a power of 10. So final answer would be 2.0 times 10. We're taking a power of 10 there, so that's going to be to the negative 8th power. All right, we got 4 practice problems down here. Remember, you're going to make sure the bases and the exponents are the same, and then combine the coefficients. If you haven't done this yourself, go ahead and pause it. See if you can figure these out. And then when you're ready, unpause it, and I'll show you how I did it. You ready? Here we go. All right, so 10 to the 4th, 10 to the 4th. Okay, these are like terms, so I can just take 8 and 3 and combine them. That gives me 11 times 10 to the 4th. So for this one, this is too big. I need to take a power of 10, which means I'm going to give a power of 10 over here. Final answer, 1.1 times 10 to the 5th power. Next, these are like terms. 10 to the negative 6, 10 to the negative 6. So I'm going to do 5 minus 2, that gives me 3, times 10 to the negative 6 power. So this negative is only going to affect the coefficient. It is not going to affect the base and the exponent. Next one, not like terms. So I got 2 options. I can either make this one smaller or make this one bigger. It really doesn't matter. I think I've been making them smaller before. So I'm going to take a power of 10 here and give a power of 10 here. So that's going to give me 12, because I gave it a power of 10, times 10 to the 7th power, because I'm taking a power of 10 there. Now we have the same base and the same exponent, so we combine the like terms. 12 and 16 is 18, times 10 to the 7th, and 18 is too big. So we're going to take a power of 10 here and give a power of 10 here. So that's going to give me 1.8 times 10, and I'm giving it a power of 10, so it's going to be 10 to the 8th power. Last problem. All right, so let's see, what are we going to do? Let's make this one smaller. I'm going to take a power of 10 here. Oh, wrong color. And I'm going to give a power of 10 here. So I'm going to make this 70. Times 10, I'm taking a power of 10, so this is 2. Okay, these are now like terms because they're both 10 to the 2nd. So let's take the coefficients. 70 minus 8, that gives me 62, times 10 to the 2nd power. And one last time, we have to take a power of 10 here and give a power of 10 here. So that is 6.2 times 10 to the 3rd. Oh, that was delicious. How'd you like that, Silvas? Hope you liked it. See you later. Keep mathing hard. Bye-bye.